Hello, I'm Charles Elashi, and it's my pleasure to welcome you to the Jet Propulsion Laboratory. Of all the places in the world, I believe JPL is the single best place to visit if you want to learn about robotic exploration of space. The lab got its start when a group of rocket enthusiasts and students at Caltech undertook a series of rocket experiments.
That was 1936. By the 50s, we were building rockets like these. Then, in 1958, in answer to the Soviet Sputnik, JPL built and helped launch the first U.S. satellite, Explorer 1.
Since that time, JPL has been our nation's premier center for the robotic exploration of our solar system.
We also operate the Deep Space Network, the vital communications link that allows us to send commands to and receive data from an armada of spacecraft.
Not a day goes by that JPL isn't involved in some new discovery, and we share that information with the public and our schools.
It's a privilege to conduct space exploration on behalf of our nation. We hope you come away understanding how the passion of our employees and their spirit of exploration motivates everything we do. We thank you for coming, and we hope you enjoy your stay.
Answering these questions requires a journey to the planets and beyond. Our solar system coalesced out of a cosmic dust cloud some 4.5 billion years ago. Most of the dust condensed into the sun, which ignited into a nuclear furnace and burst into life as a star. The sun's internal fires provide the energy for almost every living process on Earth. Now we are exploring other places in our solar system where life might exist. Our search begins with Mercury, the planet closest to the Sun. With no atmosphere to slow down meteors, Mercury is riddled with craters, a sobering reminder that the solar system can be a perilous place.
4 billion years ago, the planet Mercury was struck by a 62-mile-wide asteroid, and it created a crater the size of Texas. That's just one example of the kind of violence that happened all the time when our solar system was forming. The next planet out from the Sun is Venus, which has long been difficult for us to understand because of its very heavy atmosphere. It's got an atmosphere 90 times thicker than our own, which enables it to efficiently trap radiation and create an incredible greenhouse effect over the whole planet.
In the early 1990s, a JPL spacecraft used radar to penetrate the clouds of Venus. The result was a global three-dimensional map that revealed the surface of this hellish world, a place where even lead melts. No one expects to find life as we know it on Venus. Straight ahead is another planet. As this blue world comes into view, it is apparent that this is an entirely different kind of place. Our world enjoys an abundance of water, the great elixir of life. Making discoveries about our own planet from the vantage of space is one of JPL's proudest achievements.
We've been exploring the mysteries of Earth for many decades here at JPL, primarily using radar technologies to explore the system. We've looked at the oceans, phenomena like El Niños, La Niñas, hurricanes. We've looked at the Earth's surface in new ways, looking at very small changes in Earth's topography. For instance, a JPL radar flying on the space shuttle provided the most complete and accurate three-dimensional map ever made. We're planning instruments that can measure extremely small changes in the Earth's surface due to tectonic motion, hopefully one day enabling predictions of earthquakes as well as volcanoes.
JPL missions are also measuring the melting of ice sheets at the polar caps and atmospheric changes, including the vital ozone layer, so important to protecting life on Earth.
So while we're looking for life elsewhere, I'm proud that JPL is using space technologies to try to improve life here on Earth, as well as provide the foundation for looking for it elsewhere.
But how did life on Earth come to be? The answer may involve comets.
The icy comets are thought to be the leftover bits and pieces from when the solar system formed, and impacts of comets with the Earth's surface probably brought to our Earth much of the water and the carbon-based molecules that are necessary for life itself.
JPL has flown missions to 3 comets. Deep Space One flew past a comet in 2001. 3 years later, Stardust flew through a comet's tail, collecting dust samples that were returned to Earth. And on the 4th of July 2005, JPL celebrated the nation's birthday with celestial fireworks as Deep Impact rammed into a comet. This cosmic collision proved to be as scientifically surprising as it was spectacular. The Moon. This was JPL's first destination with a series of spacecraft called Ranger.
Mark, 2 minutes to impact. All receivers on site are go.
Early in the 60s, it actually took us 7 attempts to reach the surface of the moon, and that was with a crash landing. Kind of hard to imagine today.
10 seconds to impact. Video still good. Excellent signal strength. 3, 2, 1. Impact. Impact has occurred at 1325502. Impact has occurred. All video data was excellent right up to impact. All cameras were functioning. Transmitters were functioning properly.
We learned a lot, and we followed up the Rangers with a series of Surveyor spacecraft, 5 successful soft landings on the surface of the moon.
The Apollo 12 astronauts landed their spacecraft within sight of JPL's Surveyor 3, which had arrived 3 years earlier. They brought back to Earth a science experiment from Surveyor, one example of how robotic and human exploration can work together.
2, 1, start, and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Of all the other places in our solar system where life might exist, Mars may be the best bet. Yet the red planet is a world of extremes compared with our own. This is Olympus Mons, an ancient volcano as large as the state of Arizona. It rises 16 miles high. That's 3 times higher than Mount Everest. This gigantic scar is called Valles Marineris, and Imagine the Grand Canyon stretching from coast to coast across North America, and you can begin to appreciate the scale of this massive trench. Though there are no signs of little green men here, primitive life forms could have once, or might still, exist on Mars.
That's one major reason why, since 1997, we have been operating spacecraft at Mars 24/7, 365 days a year. From orbit, Mars seems to be telling us that in the past it was a much warmer and wetter place, wet enough that it possibly could have been water carving these channels that we see in the surface.
We know that wherever on Earth we find water, we find life. Might the same be true on Mars? That's why there's such an emphasis on finding Martian H2O, and why JPL built for NASA two now very famous robotic geologists, Spirit and Opportunity.
Light nav.
Go nav.
The Doppler signature indicates cruise state separation has occurred.
Copy that.
All systems are go for entry, descent, and landing. We are currently 6 minutes from landing.
These rovers captured the imagination of the entire world with their dramatic landings in 2004.
5, 4, 3, 2, 1, mark.
The vehicle has now hit the top of the Martian atmosphere, moving at a speed of 12,192 miles per hour. Downrange distance to the landing site is 437 miles. Current velocity 1,356 miles per hour. Expected parachute deploy in 5 seconds. 4, 3, 2, 1, mark. We are awaiting confirmation the parachute has deployed. Parachute was detected. Lander separation event has been detected. Spacecraft reporting lander is separated. We expect that radar will lock on the ground in approximately 5 seconds from now. Current altitude 8,000 feet. Moving at a speed of 173 miles per hour. We are near our terminal velocity. Spacecraft reporting that the radar is in lock and we have a good solution on the ground. Expected retro rocket ignition on my mark. Mark. Awaiting confirmation from the spacecraft that retro rocket ignition has occurred. At this point in time, we should be on the ground. Now 6 minutes, 37 seconds from atmospheric entry. Still awaiting signal that we are on the ground. Stand by. Electronic tone sent from the rover indicates that the rover has landed base pedal down, which means right side up.
Even more incredible than the first landing, the second landing Opportunity scored a cosmic hole-in-one. The airbags rolled right into this place called Eagle Crater, and when the pedals opened, the rover was sitting there next to exposed bedrock. Geological gold mine, just what the scientists were looking for. The rovers went on to find evidence that water once existed on Mars. The big question is there life on Mars, or was there life on Mars? And that will be answered by future missions.
Mars is the last of the rocky planets as we journey further out into the solar system. Next, there's a gap where a planet might be expected to be. Instead, there's a vast swarm of rocks called the asteroid belt. A team of JPLers is constantly scanning the skies to track the potential threat of a wayward asteroid hitting our planet. A JPL mission called Dawn will visit two of these intriguing objects. planets in our solar system, Jupiter could hold 1,000 Earths. Like the Sun, it's a giant ball of mostly hydrogen gas with no solid surface. For 8 years, Jupiter had a visitor, a JPL spacecraft called Galileo. This orbiter explored not only Jupiter, but also the giant planet's 60-plus moons, each a fascinating world.
Jupiter's moon Io is, at first glance, like a giant pizza. It looks like a pepperoni pizza. Io's caught in a gravitational tug-of-war between Jupiter and the other moons. The result is that Io has constant volcanic activity. It has big eruptions, big lava flows, is constantly in turmoil. If Io is fire, Europa is ice. Europa has an icy crust, but we think it has an ocean underneath this icy crust. And in this ocean there are volcanoes. If you have heat from the volcanoes and you have liquid water, those are two conditions necessary for life. And that's what makes this moon so fascinating to us scientists. We want to go back and look to see if life is there.
Next comes the solar system's majestic gem Saturn, the most serenely beautiful of all the planets. Saturn's rings are made of ice and rock particles, some as small as dust, others as large as a house.
If you're a planetary scientist, Saturn has it all. We have the rings, which are bigger and brighter than any other planet, and of course, Saturn itself.
In 2004, Saturn welcomed its first orbiting visitor, the JPL-built Cassini spacecraft.
Wait, SWACOM. Go ahead, SWACOM. The Doppler has flattened out.
While Saturn and its rings have been bewitching to gaze upon, the biggest surprises have so far come from the Saturnian system of moons. Phoebe was the first moon Cassini trained its cameras upon. This was the best image we had of this moon before Cassini. This is Cassini's image. This strange object is believed to date from the time of the formation of the solar system. This is Mimas. It once suffered an impact so large that it nearly disintegrated. If you want to know what our planet was like when life first appeared, Titan may provide answers. Scientists believe that Titan's atmosphere resembles that of the primordial Earth. Cassini is now mapping Titan with its powerful radar. What is learned will add to the knowledge gained by the European Space Agency's Huygens probe. The probe hitchhiked to Saturn aboard Cassini and then descended down to Titan's surface. But it is Enceladus that has astonished scientists. This moon appears to have rolled over on its side. One result is that at the South Pole, where it should be the coldest, there seems to be an unknown heat source that is gushing up water like a Yellowstone geyser. Dubbed Cold Faithful, scientists were amazed to find evidence of water so far away from the sun. If true, the number of places in the solar system suitable for life may be much larger than ever before imagined. Next, we catch sight of Uranus. While Earth is blue because of its water, this planet's color comes from an abundance of the gas methane. Uranus has had only one visitor, Voyager 2. After Uranus comes the planet Neptune, also visited by Voyager.
This planet receives only a glimmer of sunlight, so we expected to find a subdued world. But instead, Voyager found the windiest place in our solar system. Voyager took this image of a storm called the Great Dark Spot, and it was as large as our entire Earth. Only Pluto, which is the smallest of our traditional planets, remains unexplored, but NASA has a mission on its way there now.
Voyager 1 and 2 are now headed toward interstellar space. The vastness of space is almost unimaginable. The physical distances seem insurmountable. Even today, we have barely crossed the threshold into the larger universe that is all around us. But we can know about these distant places through telescopes. And from the vantage of space, we can behold glorious sights.
JPL has been a major contributor to the building of a fleet of spacefaring telescopes. Advances in technology now have astronomers near the point where they're almost able to image planets around other stars. Already we can see these swirling disks of debris around stars that might someday form planets, and we can also find large Jupiter-sized planets as well. But now, JPL is actually busy designing telescopes that are going to be able to hunt down those rocky worlds, those small Earth-like planets. And by studying their chemical makeup, we actually might be able to detect signs of life on a distant planet. When that happens, our world is never going to be the same.
The more we know, the more questions we have. And the ancient questions remain. What is out there? How did it all come to be? What will be our fate? But this much we can say. Every atom in your body was once inside a star. So the next time you look up into the night sky, remember, you are, quite literally,